In this video, we're going to talk about finding critical numbers. So first off, I need to tell you what critical numbers are. A critical number c, or a number c, is a critical number of the function f of x if, number one, c is in the domain of f, and number two, the derivative at c is 0 or the derivative at c is undefined. Okay, so a critical number is a number in the domain of f at which the derivative of f is 0 or the derivative is undefined. Okay, so that's it. It's a pretty straightforward and simple definition. One thing to be kind of careful of is knowing what the domain is, right? And then this part here can be sometimes a little bit tricky, but not really for the reasons that you might think. All right, so let's just take a look at a basic example, and then at the end we'll talk about the general steps that you should take to find critical numbers. All right, so we want to find the critical numbers of f of x equals x cubed minus 2x squared plus x minus 5. So the very first thing that you need to know is the domain of f, right? So that's the first thing that you need to do, because the critical numbers are numbers in the domain of f. So if you don't know what the domain of f is, then it's kind of hard to tell whether the numbers that you get are in there or not. Okay, so this function that we're looking at here is just a polynomial, right? That's one of the nicest types of functions that we talk about. The domain of any polynomial is all real numbers. So that's pretty straightforward and easy on this problem. In some other problems, it's a little bit more complicated or difficult. You need to know about the domain restrictions of the functions that you talked about in pre-calc and those sorts of things like that. All right, so next up, now that we know what the domain of f is, we want to take the derivative of f, and you want to simplify as much as you possibly can. Okay? All right, so here taking the derivative is easy. It's just a polynomial, so we just use the power rule to take the derivative, and we get 3x squared minus 4x plus 1 as the derivative here. Okay. Next up, we want to solve the equation f prime of x is equal to 0, right? Critical numbers come in two types, right? The types at which the derivative is equal to 0, and that's what this part is designed to get at, right? So we want to solve that equation, and that will tell us where possibly the critical numbers that make the derivative 0 are located. All right, so here's the derivative. We set it equal to 0 and solve that out. This polynomial is just a quadratic, and it can be factored to 3x minus 1 times x minus 1 equals 0. So now that we have the left-hand side completely factored and it's equal to 0, then we can just set each factor equal to 0 and solve those factors, each factor equal to 0 out, and we get x equals 1/3 for this one and x equals 1 for this one. Okay. So just make sure that you check to see that those are actually in the domain of f, right? And since every number, right, every real number is in the domain of f, then these two certainly are. So these are critical numbers of f. Okay, they are places at which the derivative of f is equal to 0 here. All right, next up, you need to find where the derivative is undefined. Okay, so in this case, the derivative of f is also a polynomial, and so its domain is all real numbers, right? That means it's defined everywhere. So we don't have to really worry about those types of critical numbers in this one. And we will do a couple examples after this so that you can see how that case is handled in some situations. So in this example, the only critical numbers that we found were 1/3 and 1. Okay. All right, so some general steps for finding critical numbers of f. This is going to depend quite a bit on the type of function that you're dealing with. So, but the general steps would go something like this. Number one, you always need to be aware of what the domain of f of x is, right? Step two, right, you want to find the derivative and simplify that as much as you can. Okay. A lot of times if you have fractions involved, you're going to have to simplify that out and get the derivative written as one big fraction. That's the preferable method of having that written out. So to be honest, this part, step number 2, is the part that trips people up the most. It's not really the calculus part of it, it's the just algebra part of it, trying to simplify these expressions and get them into some useful format. Once you do that, then solve the equation f prime of x is equal to 0 and check to see that those solutions are in the domain of your function. And if they are, then they're critical numbers, right? If they're not in the domain, then they're not critical numbers. Finally, you need to find where the derivative is undefined and check to see if those numbers are in the domain of f. We didn't have to do that in this first example that we did, but in the next 2 examples, I'll show you how to do that. Okay. And so those are the general steps for finding the critical numbers of f. Remember, it's going to vary. The stuff that you do to solve, to find these critical numbers, it's going to vary depending on what the type of function is. Also, notice we really haven't talked about why you would want to find these critical numbers, right? And we will talk about that in later videos also, the importance of these critical numbers.